This is Matt, 2021, question 1E. We're given 6 vectors v1, v2 up to v6, which are chosen to be either 1, 1 or 3, 2, with equal probability, and they are independently chosen. We want to work out the probability that their sum, v1 plus v2 plus v6, is equal to 10, 8. So then the question is, how can we get 10, 8 from combinations of 1, 1 and 3, 2? And how many 1, 1s do you need and how many 3, 2s do you need? So let's suppose there are K1, 1s and M3, 2s. Well, because we only have 6 vectors, we must have that K plus M is equal to 6. And we want them to sum to 10, 8. So we want K1, 1 plus M3, 2 is equal to 10, 8. And this gives us two separate equations, namely the top row of the vector and the bottom row of the vector, which means that K plus 3M is equal to 10 from the top row, which is equation 1, and K plus 2M is equal to 8 from the bottom row. And these are two simultaneous equations which we can solve. And we see that if you do equation 1 minus equation 2, we get that M is equal to 2. And then plugging this back into equation 1 gives us that K is equal to 4. And we do indeed see that M plus K is equal to 6. Okay, so we must have 4 1, 1s and 2 3, 2s. So how many ways can you choose our 6 vectors to get 4 1, 1s and 2 3, 2s? Well, that's precisely saying out of 6, we choose 4 of them to be 1, 1s and 2 of them not to be 1, 1s, as the only 2 options. So there's precisely 6 choose 2 or 6 choose 4, which is equal to 15 combinations of choosing 4 of these and 2 of these. But how many combinations are there in total? Well, because each one can be either 1, 1 or 3, 2, they're precisely 2 to the 6, which is equal to 64 total different combinations of v1 up to v6. So the probability, because they are each choice is equal probability, is precisely 15 over 64. So the answer is B.